Hey guys, we have this iPhone 8 Plus in here. I have it hooked up to DC power and a test screen on. Checking DC power. Clicking output on DC power, we have a full short. It's drawing 5 full amps, so there's a short on the main power rail. We're going to start by switching to the microscope view. Overhead cam here. And disconnect the test screen. Yeah, so right when we click output, we're drawing 5 full amps, and the device is getting very hot. So I'm going to turn that off. Switch to the microscope view. I'm going to do a quick visual inspection of the main board here. Board looks perfect, no signs of water damage or anything like that. I was checking the notes. This device actually came in for a battery replacement, which was diagnosed, of course, by the customer, but it's obviously not a battery swap. There's a short somewhere on, probably on VCC main. VDD main on this device. First thing I'm going to do here, I'm just going to check for a short on VDD main. So we do have a short on VDD main. Next thing, I'm going to switch back to the overhead cam. Going to grab our thermal imager. We're going to use this to identify which area of the board the heat is coming from, and see if we can zero in on where the short is on VDD main. Switch to the thermal view and outputting power. So the source is getting hot, which is normal. Check this side. Might be below there. So we're going to remove these stickers. Alright, with the stickers removed, I'm gonna output power from our DC it once again. So we can see right there it's lighting up. Somewhere in this region here. Let's check ZXW. See where VCC main exists in that area of the board. Interesting. So any of these points. So I'm gonna try using freeze spray now and see if we can identify the exact component that's heating up. Alright. So, right there. And that is in fact a VCC main point. So it looks like we've found our culprit. Alright, so C5695 is our culprit on VCC main. Let's I'm gonna remove it from the board. So for fun, we can grab our multimeter in continuity mode and test this capacitor. If we get a beep, it means it has become a wire, and that is why we were short to ground. So this cap is in fact a wire, which was shorting the entire device to ground. So if we take a reading here on VCC main where we remove the cap in diode mode, we should get normal readings. So that's ground, and then 0.3, which is perfect. Sorry. So you can see here that the short has been relieved. Now we can go ahead and test this device. Switch the overhead view. Alright, we have our test screen here, and we're hooked up to DC power. It's prompt to boot. Okay, so we have an Apple logo. We're drawing 300, 500, 600 milliamps, which is good. We have a normal boot sequence. And we're just going to see if we can get to the passcode screen. Perfect. So we have a full boot sequence. So as a recap, we had this phone came in completely dead. It came in for a battery replacement according to the customer. But it was not a battery replacement. We had a full short on VCC main. Using the thermal imager, we were able, and freeze spray, we were able to narrow down the exact component. We removed it from the board, and the phone has been repaired. We will go in, get the device fully assembled, and back to the customer. Thanks for watching.